I'm recording already. Yeah. Okay. All right. Okay. So today, we will start with chapter 1. Okay, electrostatics. Okay. Electrostatic is about positive charge, negative charge, electric field. Attractive force between positive and negative charge, repulsive force between same charge, positive with positive and negative with negative. We have repulsive force. Yeah. So those are okay. So right. So electrostatic is a branch of physics that studies electric charge at rest. Okay. Right. So in this topic, we have four subtopic. Coulomb's law, okay, electric field, electric potential, charge in a uniform electric field. So these are the things. Yeah. So okay, so these are the things you must achieve. Yeah, you must know how to state the law, Coulomb's law. Yeah, this is the Coulomb's law, KQQ over R square. Sketch the electric force diagram, and then apply the Coulomb's law for a system of charge. You need to do calculation for this. Okay, have a maximum of only 4 charges. Only maximum of 4 charges. So that's our syllabus. Okay, and electric field. Okay, so today we are not going to enter electric field lah. So today we only learn about Coulomb's law. Okay, we try to solve some problems under this subtopic. Okay, so others take. All right, so now Coulomb's law. Okay, so Coulomb's law states that what is Coulomb's law? Coulomb's law is about electrostatic force. It's all about force. Force is unit in Newton. Yeah. Coulomb's law talks about force. F. Between two charges separated by a certain distance r. And he said that this Coulomb's law, he said that this force, electrostatic force, is directly proportional. That means force is directly proportional to the product of the charges Q, two charges actually, between two charges. That's why we have Q and big Q and small q. Okay, so between product of these two charges, so this force is directly proportional, and also inversely proportional to the square of separation distance between the two charges. So yeah, force is directly proportional to the charge and inversely proportional to the distance. So what I can say is like this. So let me write it out here. So Coulomb's law is about this force. Okay. The definition of Coulomb's law. Definition of Coulomb's law is proportional to the product of two charges over distance. What it means is, the bigger the charge, the bigger the electrostatic force. And we normally write it as Fe lah. Electrostatic force. The bigger the charge between the two charges, the bigger the force. The smaller the distance. Smaller the distance, then also bigger the force. Because inversely proportional. So it means we have two charges. Let's say we draw it out. We have two charges here, and a charge. Okay. This. Okay. So we have okay. Let me. Okay. So this charge is capital Q, and this one is small q. We also can write it as Q1, Q2. That means we also can write the formula as Fe proportional to Q1, Q2 over R squared. Also can. Either way, you want to make a capital, small, capital letter and small letter, or just put as Q1, Q2 also can. Either way. yeah, separated by a certain distance. That means from the center of first charge and center of the second charge, the distance separated, yeah, center to center. Oh, sorry. That means the distance r, put it as r. So you know, if let's say these two charges, they are both one is a positive charge and another one is a negative charge, you know. So in between them, they have this electrostatic force. So because positive and negative, they attract each other. So they have this electrostatic force in between them. Positive and negative attract. So this attractive force will become bigger, much bigger attractive force if the charge, both charges, if they have a bigger charge, then they have higher electrostatic force or attractive force between them. Okay, and but distance, about distance is inversely proportional. That means the smaller the distance, that means the nearer of these two charges to each other, if they are nearer to each other, then they have smaller distance, they also have bigger force. So this is what we call Coulomb's law. This is what we call Coulomb's law. Coulomb's law is talking about this electrostatic force. Understand? Proportional to this charge. And what I want to say is this equation later can be relationship can be written in a form of equation. We have equation, we can write it as we have a constant value there, kq over r square. K is a constant value. We also can write it as, you know, because k is actually 1 over 4 pi epsilon naught. 1 over 4 pi epsilon naught. So we can write the equation again in another form. We can write it as q over 4 pi epsilon naught r square. It's a bit longer, you know. K we substitute with 1 over 4 pi epsilon naught. So it becomes longer equation. Normally we use a shorter one. This equation, okay. Normally we use this kq over r square. We also can use this formula. Yeah. So yeah, that's all about Coulomb's law. You know. And just now, what is the value of k? Yeah. What is the name of k actually? And what is the value of epsilon naught? So these two values, k and epsilon naught, you can find the value in the list of constant. So k value is 9 exponent 9. Yeah, 9 exponent 9. K is what we call Coulomb's constant. 9 exponent 9, and this is the unit. And epsilon naught, this one epsilon naught is called permittivity of free space. The value is 8.85 exponent negative 12 farad per meter. Okay, it's called permittivity of free space. K is called Coulomb's constant. And okay, here we have Q equal to Ne. Okay, what does this mean is charge is actually accumulation of many electron charge. You know, how to build charge? Yeah, you know, remember. Okay, right over here. Okay, you remember the experiment? Yeah, do you still remember the experiment that you have a comb? Okay, you have a comb, and then you rub a cloth, yeah, a cloth with against a comb. Yeah, this is a comb. Okay, You rub it, you rub the cloth on the comb, and then this comb later able to attract, pieces of small pieces of paper. It can be attracted to the small pieces of paper. This is called electrostatic. Yeah. Why? Why the cloth can, after you rub the comb with a cloth, and the comb able to attract the small pieces of paper? Because they have, it experiences the electrostatic force. Okay. Because of electrostatic force, yeah, they attract, this, what we call the paper. Okay, so this is what we call electrostatic force lah. Okay, so do you know how to build this electrostatic force on the comb? Yeah, do you know? Okay, so you know why you need to rub the cloth on the comb? Because what I want to say is, this comb initially is neutral. Initially is neutral. Neutral means what? A neutral atom. Yeah, let's say a neutral atom. What do you mean by neutral atom? Neutral atom means you have equal amount of proton and neutron, electron. Let's say we have 10 proton in this atom, and we also have 10 electron in this atom. So they are neutral, isn't it? They are neutral. So when let's say this atom suddenly it lost one electron. That means one electron go out from the atom. What happened to this proton? This neutral atom, so it lost one electron. Let's say this atom lost one electron. So what happened to this atom? It become a single positive charge, isn't it? It becomes single positive charge. Do you understand, class? I mean, can you catch up with what I'm explaining? Yeah, give a thumbs up if you okay. Yeah, following. All right. So let's say this atom it lost one electron. So that means it only has 9 electrons left. Yeah. So it become unbalanced. The proton now more than electron, isn't it? Proton now more than electron. So it becomes single positive charge. So same thing. When you rub the cloth on the comb, yeah, initially the comb is neutral. Neutral means you have equal amount of proton and electron. 10 proton, 10 electron initially. But when you rub the cloth on the comb, this comb will lose electron. The electron from the comb will go to the cloth. The electron will transfer to there. Transfer. So it lost electron. The comb lost electron. So what will happen? It become positively charged. This comb become positively charged. Understand? Positively charged. So let's say you lost two electron. So then you only left with 8 electrons, isn't it? You left with 8 electrons. So it become 2 positive. Correct or not? If you lost 3 electron, then it become what? It become only 7. So this one become 3 plus. Alright? So this so that's why we have this formula. Yeah, we have this formula Q equal to NE. You know Q equal to NE. So this Q is actually this 3 plus. Understand? The charge built up in the this one is no longer neutral lah. It's no longer neutral. Yeah, it become it's no longer neutral. It become a charge already. Yeah, it become a charge already. Yeah, it become a charge already. So okay, the charge refer to it's all because of loss of electron. Loss of electron. So charge is actually number of electron multiply the charge of one electron. So for example, I give one example. Let's say I have two atoms. Okay. So you have 10 proton, 10 electron, 10 proton, 10 electron also. Let's say suddenly this is the first charge, second charge. The second charge lost 3 electron. The second charge lost 3 electron to the first charge. So what happened is the first charge has 13 electron now, and the second charge now has only 7 electron. So what happened is this one become 3 positive, and this one become 3 negative, isn't it? So how to calculate the charge? So the charge is equal to N times E. So this one is 3 times, because 3 positive, right? 3 positive. So this one become, charge of 1 electron is 1.6. Ataupun just write as 3E lah. The charge is for this the second charge. Yeah. I mean this Q2, this Q1. Okay. This Q2 now is positive 3E. Understand? The charge built up is all because of electron. This one lost electron. This one lost electron. This one gain electron. Understand? So this Q2 become positive 3E, and this Q1 become how many? Become negative charge, isn't it? So that's why you get a negative charge, negative 3E. Understand? And then the charge of 1 electron is 1.6 exponent negative 9. Exponent negative 19 Coulomb. Okay. So this is why is positive 3E, because it lost 3 electron. This one gained 3 electron. So this one negative 3E lah. Understand, class? That's why we have this formula. That's why we have this. Where is my? That's why we have this formula. Charge is all because of gain, lost electron or gain electron. If you lost electron, it become positive charge. If you gain electron, if the atom gain electron, then it become negative charge. So Q got positive, negative lah. Okay, so you see, charge of 1 electron is 1.6 exponent negative 19. Okay, so let's look at this graph. You see, force versus the distance. So as I said just now, the further the distance, yeah, if the further the distance between the two charge, the smaller the force between them. So where is it? So inversely proportional lah. If you put it in 1 over r square, then become a straight line, and the gradient is k cube q. Yeah. Okay, so yeah, and then the force is directed along the line joining the charge. So you see, attractive force, if the two charge have opposite sign, if one is positive, one is negative, then it is attractive force, attract each other. If same sign, positive, positive, ataupun negative, negative, then the repulsive force. Okay, opposite sign they attract, same sign they repel. Positive, positive, ataupun negative, negative, they repel. And then the way we write the notation F12 or F21. Okay, class, I want to tell you something. Here is mentioned here. They are equal in magnitude but opposite direction. So that means they are Newton's third law, action-reaction force. Okay, now before that, F12 is the force exerted on Q1 by charge 2. Yeah. So F12, you see here, F12 is force on Q1. Force on Q1, you see here F12 kan. F12, 1 means on Q1 due to Q2. due to charge 2. And then F21 is on Q2. F21 means what? F21 means force on charge 2 by charge 1. Okay? So this one also lah, yeah. F12 means on Q1 due to Q2. F21 means on Q2 due to Q1. Okay, let me show you one example. Okay, one example. So let me just draw. Let's say I want to draw 3 charge. Let's say I want to draw 3 charge. I put this as okay. This is one is positive. Right down first. Positive Q1, negative Q2, positive. I put negative Q3. Okay, class. I want to ask you. I want you to draw the force on Q2 only. Draw the force on Q2 only. So how? So how to draw? Let example. So on Q2, okay, on Q2 we have 2 is attracted to Q1. Q2 is attracted to Q1, isn't it? Because they have opposite sign, positive and negative. So it's attracted. So I must draw like this. F. This one is F on F what? This one is F what? F on 2, right? F on 2 due to 1. This one it means F on 2. F on 2 due to 1 ataupun by 1. F on 2 due to 1. Okay? And then for Q2, between Q2 and Q3, they have negative. Repulsive lah. They have repulsive force. So this was is F23. That means this one is F on 2 by 3 lah. By 3 or due to 3. F on 2 due to 3. Or on 2 by 3. Okay? And repulsive force. So so how to find the resultant force on Q2? This is the resultant force. So this is the resultant force. Resultant force. I mean the resultant force on charge 2. Yeah. So we need to have direction some more. You have to find angle theta, everything. So Pythagoras theorem lah. You have to find F21, F23, and then these two combine, you get the resultant force. So how to find the we need to find the formula. We need to use a formula. What F21 means F Q1 Q2 over distance between them. Between 1 and 2. This is R12 lah. R12, and then distance between 2 and 3 means R23. Understand? So you have to find F21. Use the formula KQ1 Q2 over R12 square or R12 square, and then you also need to find first the F23 equal to KQ2 Q3 over R23 square, distance between 2 and 3. So you need to calculate the value, this one, and then Pythagoras theorem. So you need to do xy component, xy component, or the xy. Sometimes you need to resolve, you need to resolve vector, resultant vector, find the total f, resultant vector. Understand? To find the total f. This is what you're going to learn in first subtopic lah. In problem solving later on. Yeah, apply the Coulomb's law. You have to find the force first. Yeah. Okay. And then you know, this yeah, of course, I only draw the force on Q2, but on Q1 also have their own force. You must know the target. Dia suruh lukis di mana. Kalau suruh lukis di Q2, lukislah force dekat Q2. Kalau lukis force dekat Q1, kena lukis force dekat mana? Dekat Q1. Understand? You must draw the force on Q1. If you draw the force on Q3, you draw the force on Q3. So only draw the force on the target only. Only draw the force on the target. Don't draw the force on all charges. On Q1 ada force dia, on Q3 ada force dia, but tak payah lukis, ya. Only draw the force on the target. Understand? Okay. Yeah, like you see Q1 and Q2, Q2 ada F21, Q1 pun ada F12 lah, understand? Dia ada force dia juga, F12 juga. Tapi jangan lukis. Tapi okay. F12 dan F21 adalah sama. Mereka adalah force yang sama, ya. Tapi jangan lukis. What I want to say is here got, yeah, if you look at these notes, it say F12 and F21 they are equal in magnitude but opposite direction. Because they tengok equal sign, sama besar, tetapi negative sign. Negative sign means what? Opposite direction. Okay, here is a very important concept I need you to know. That is, kalau saya ada satu charge besar, charge tadi kan kita sudah belajar Q sama dengan NE kan, Q sama dengan NE kan. So let's say now the first charge is, okay, saya guna huruf kecil je lah. Q1 is let's say is 10 electron. Let's say it's a positive charge, 10 electron. And then Q2 cuma charge kecil je. Q2 maybe charge kecil. Maybe it's only negative 2 electron. Yeah, negative 2. So how? Positive charge, negative charge, they attract each other, isn't it? Attract each other. Okay? Attract each other, Fe, Fe. Okay. So, which one have a bigger charge? So Fe, we write it as what? Kalau F on Q1 is F12 lah kan? On 1 due to 2. Kalau on 2 is F21. So, siapa lebih besar? Siapa punya force lebih besar? Oh, maybe you say on Q2 dia ditarik lebih kuat kepada Q1, ya. It pull much harder to Q1 than Q1 pull to Q2. Actually, no. They have the same force. We don't look at the size. F12 is actually equal to, is negative because they are opposite direction. They are equal in magnitude. Understand? They're equal in magnitude. So what I want to say is if the magnitude is the same, they are what we call action reaction. Same direction, same magnitude, opposite direction. This is what we call Newton's third law. Yeah, big charge, small charge, same force. Big charge, small charge, same force. Because to calculate this force between them is the formula. They use the same formula. K Q1 Q2 over R12 square. So on Q1 also the formula K Q1 Q2 over R12 square. On Q2 also K Q1 Q2 over R12 square. They have the same formula to calculate the electrostatic force between them. So don't say big charge attract small charge much harder than small charge attract big charge. They attract with the same magnitude. They attract with the same force. Understand? Same force, same magnitude, opposite direction. Same magnitude, opposite direction. Okay. Now, note, the sign of charge can be ignored when substituting into the Coulomb's law equation. The sign of charge is important in distinguishing the direction of the force when we draw the electric force diagram vector. Okay, the sign of charge can be ignored when we substitute into Coulomb's law. So look, okay, let's look at example. Sketch the electrostatic force on Q2. So force on Q2. So F21, F on 2 due to 1. Because this is positive charge, this is negative charge. So this force attract towards positive negative attractive kan. Attract towards Q1 lah. Okay. Draw the force vector on charge of interest only. Draw the force on the target charge only because the target is Q2 kan. Target is on Q2, so only draw the force on Q2. Tak payah lukis force on Q1. Understand? Direction of force and notation between the two charge for charge 2 only. Why charge 2 only? Because charge 2 is the target. Follow the instruction. Instruction ask you to draw on Q2, you just draw on Q2. Don't draw on Q1. Okay? Left out the negative sign for Q2. Substitute magnitude of charge only. So when we calculate the magnitude, F, the charge, we ignore the negative sign. We don't substitute the negative sign here because we don't want to confuse ourselves. Okay, I will show you how to calculate. I will show you how to calculate. Positive and negative, they attract. Positive and positive repel, negative, negative repel. So, positive and negative, they attract. If opposite sign attract, same sign they repel. Okay. So that means here he said left out the negative sign. It means what? It means like when we want to calculate this one, we want to calculate this one. Okay. Let me show you. Okay, just now I used electron, right? Actually, charge, the unit is not electron. The charge unit is Coulomb. The charge unit is Coulomb. I don't want you to get it wrong. Yeah. So the charge is actually unit Coulomb. Q is Coulomb actually. Yeah. But this Coulomb is made of multiples of electron. Okay. There are so many explanations. Okay. So let me tell you something. So let's say I have a charge. This charge. Let's say I say this is positive 1 Coulomb. You understand what is it mean by positive 1 Coulomb? So you can actually calculate how many electron in 1 Coulomb. You can actually calculate one Coulomb got how many electron. So how many electrons? So you just substitute lah. 1 Coulomb electron charge is 1.6 exponent negative 19 Coulomb. Okay, so how many electron is in 1 Coulomb? Let's calculate, class. Let's calculate, Let's calculate. Come on, class. Calculate. Use your phone to calculate. 1 divided by 1.6 exponent negative 19. Okay, so so in 1 Coulomb, it has 6.25 6.25 exponent 18 electrons there. In just 1 Coulomb, there's so many electrons. That means kalau ini charge ini 1 Coulomb, maksudnya dia ada berapa elektron? Charge ini ada 6.25 6.25 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 elektron there. Kalau dia positive 1 Coulomb, kalau dia positive Coulomb, maksudnya dia lost this amount of electron. Understand? Kalau positive 1 Coulomb, that means it lost this amount of electron to elsewhere. Elektron dia sudah hilang begitu banyak elektron dalam 1 Coulomb ini. Itu maksudnya 1 Coulomb. Okay, good. So what else? Okay. Okay, so what should I do? Okay, tadi saya cakap apa? Yeah, left out the negative sign to calculate the force. Okay, so let's say I'll calculate the force between them. So I give this example here. Now Q1 is positive 10. Let's say positive 10 coulomb. Let's say Q1 is positive 10 coulomb, and Q2 is negative 3 coulomb. I don't put electron anymore because actually charge is in the unit of coulomb. Yeah, negative 3 coulomb. Okay, so what is the electrostatic force between them? So they have attractive force, isn't it? Because they have one is positive, one is negative, so they have this is this is what F12. This is F21. So the magnitude of F12 is equal to magnitude of F21. No matter big charge or small charge, they have the same force. So they use the same formula KQ1 Q2 over R square. Okay, so here he say ignore. Just now you can see here he said ignore the negative sign, kan? Substitute the magnitude only. Yes, that means if we want to calculate the magnitude of force, we ignore the negative sign. So the charge ignore negative sign. The charge ignore negative sign on Q. Okay, especially this is a vector. This force is a vector. If it is a vector, we ignore the negative sign. Understand? But later, if you study, you learn electric potential. I don't need to get confused. Kalau electric potential, you must preserve the negative sign. You must substitute the negative sign. There's some difference here. Yeah. So right now is to find the force, which is a vector. That when you want to find the value of force, we ignore the negative sign. Okay, we ignore the negative sign. So we just substitute like you see here, Q2 got negative kan? Ignore the negative. Don't substitute the negative. We just substitute as positive 3 coulomb. Okay. Okay. K is what? K is 9 exponent 9 kan? 9 exponent 9. And then Q1 is 10 coulomb. And then Q2 is negative 3 coulomb. So just put as 3 only. Don't put the negative sign. Ignore the negative sign, yeah? And then distance between them, let's say this is 10 meter. 10 meter. So just put 10 square lah. Yeah, 10 meter square. If let's say this is in cm, then you must change the unit in meter. So divide by 100 0.1 square lah. Okay. So calculate. Then you can calculate. Yeah, the value must be in positive. Yeah, the unit the force is in Newton. Understand, class? So I think today until here lah. Saya tak sempat nak bincang soalan. Okay? Tak sempat nak bincang soalan ni. Soalan electrostatic. But the coming this afternoon lab we will discuss question lah. Yeah, on electrostatic force. We solve the tutorial questions. Okay. So this we will Google Meet this afternoon during lab. Okay, to apply the Coulomb's law. Okay, so that's all for today class. Okay, I mean for this morning class. Okay, so can you understand, class? Yeah. Good. So okay, see you in the afternoon. Okay, can left the chat room already. Thank you, class. Sure.